Okay, now here for question 11, we start to see these percentages, and I want to show you guys there's a trick that makes these be not too bad. You just got to make sure you think about them the right way. Um, so this is another first order reaction that we have, and so when you see first order, we right away want to grab this equation. But we don't have any concentrations to put in there until we digest the problem just a little bit. So this reaction says that it is 25% complete after 26 seconds. So what that actually tells me is 25% complete. Well, this reaction doesn't care, or this equation doesn't care how much complete the reaction is, it cares how much remains. But we can figure that out since the total amount of the substance, of course, is 100%. So 25% complete means that 75% remains. And that's what our equation is tracking, how much of the chemical is remaining in there. Once we have that in hand, we can do a little trick and say that our reaction has went from 100% to 75% over the course of 26 seconds. And now we can kind of fudge those concentrations that we're going to put in. I'll show you what I mean by that. So ultimately, I'm going to need to figure out a K here. I'm going to use this equation again. I'm going to need a K to be able to go back and do that. And so check out the trick that we're going to pull right here. So we're going to say okay, A at time t equals 26 seconds is 75 molar, starting from a concentration at time 0, which was 100 molar. Okay, that gives us the right ratio. And that's all that matters for this equation. So over the course of this 26 seconds, we went from 100 molar to 75 molar. And now this should look like something that you've practiced. So natural log of 75 is equal to natural log of 100 minus K, and the time is 26 seconds. I'm doing a few algebra steps here together, sure that it makes sense to you. Okay, natural log of 100 minus natural log of 75. I'm going to divide that by 26. 1.11 times 10 to the minus 2. And my unit here is second to the minus 1. All right, well, I stacked quite a few things in this problem. So it asked how much longer would we have to wait for it to go down to 99%. We can approach this a couple of different ways, and one of the ways, in a way that I'm going to approach it here, is to go from the 25% complete down to the 99% complete. Let me show what I mean by that. 99% complete means that 1% remains. And since the question asked me how much longer this would take, it's asking how long does it take to get from the 25% complete to 99% complete. Well, at 25% complete, we said it was 75 molar, and this we'll just call 1 molar. Okay, we're going from 75 molar to 1 molar. Again, our equations are not going to care. Natural log of 1 molar equals, we started out with 75 molar. We have a K now to put in, 1.11 times 10 to the minus 2. And now a time is what we're solving for because we want to know how long this would take. And it would take about 390 seconds to get from 25% complete down to 90.